Hello, good afternoon. So good afternoon. Welcome to the close. So if you have any questions, you may just type it here, or you may just ask here. Regarding there are some queries in the discussion forum that regarding the exam pattern, exam question pattern. So that is actually you will get every week this assignment for the course, and the question in the exam paper will be similar like whatever you will be solving in the assignments. And you need to you will have total 50 questions in the final exam, and in between, say whatever questions you have, you can post it in the discussion forum. We regularly check this discussion forum and we'll just answer and reply to your queries. And today, if you have any questions, whatever these videos you have already gone through, you please, if you have any doubts, you please ask it here. Thank you. Good afternoon. So one question is there that which programming language should we use for solving CFD problems? It depends on you that in which language you are comfortable with. Say earlier we used to use Fortran 77, then we have used C, C++. Nowadays students are using Python also. So whatever you are comfortable with, that you can use. Generally for CFD problems, we do not use MATLAB, but it can be also used. So to learn any this algorithm, the CFD algorithm, it is better that you use any programming language like C, C++, or Fortran, and uh, and solve the simple problems as discussed in the class. If you have any further questions, you may write it here. If you do not have any background in programming, then you can start with C or C++. So it is better. And it will be very useful not only for CFD programming, in other courses as well. So practical turbulence modeling, you actually generally students are using ANSYS Fluent, and just they select the different turbulence modeling like two equation model like K epsilon and K omega. But if you want to write your own turbulence model solver, then obviously first you have to write the Navier-Stokes solver, right? So you have to solve the Reynolds average Navier-Stokes equations. So or if it is laminar, then only Navier-Stokes equation you solve, then you try to modify this for RANS, where you need to add for the turbulent viscosity, right, in the viscous term. And now to calculate this turbulent viscosity, you need to solve some other equations, one equation model or two equation models like K epsilon and K omega. And when you use two equation models, then additionally you need to solve two equations, right? K equation and epsilon equation, or K equation and omega equation. That any turbulence book you can find, or any fluid mechanics book you can find the governing equations. And the way you have written the solver for momentum equations, similar way you can actually write the solver for the turbulence model. And once you solve the K epsilon or K and omega, then from there you will be able to solve the calculate the turbulent viscosity. And once you know the turbulent viscosity, that you can use it to solve the Reynolds average Navier-Stokes equation or RANS equation. Thank you. If you have any further question, please post it here. The students, if you dear learners, so if you want to interact with me, you can also join through the MS Team links, and we can interact through this online mode. So there are a couple of questions. One question is that I also want to learn coupled field tangent field in ANSYS, how coupling equation works. So I am not getting exactly what you want to know. So what I understand that, say, if you are solving the natural convection problem, then those are actually two-way couple. The momentum equation actually depends on the temperature field because due to the buoyancy, and the energy equation obviously depends on the velocity field. So you need to solve these equations simultaneously in a coupled way. So that I just understood from your question. So if you are trying to understand something, you are asking something else, you please post it here. Another question is that what should be my next direction after completing this course, NPTEL course or FBM or course on modeling turbulence. So this course is a basic course where you learn the basic discretization schemes like finite difference method, finite volume method, and difference terminology. Then how to discretize the diffusion equation, convective diffusive equation, and then finally we have discussed about the discretizing the Navier-Stokes equations using different schemes like simple algorithm, simplex algorithm, simpler algorithm. So at first, if you want to learn the CFD, then you have to write your own solver. Okay. So that you can understand the algorithm, which way it works. Then if you want to have means other courses, you can actually do some courses on finite element method or say finite volume method. In detail we have already covered in this course. Okay, but if you want to know some industrial applications or some means you are telling modeling turbulence. So if there are some courses which so you can actually do those courses. But turbulence modeling, actually, if you solve the Navier-Stokes equation yourself, then it will be easier for you to write the solver for the this turbulence equation K and epsilon. That I can tell you. Only some understanding of turbulence is required, and for that you have to have some background on turbulence. Okay. Thank you. If you have any question, please post it here. So we'll wait for another 3-4 minutes. So if you do not have any other question, then we will close the session. Okay, thank you. So we'll close the session now. If you have any further questions, please post it in the discussion forum. Okay, we'll just reply to your queries. Thank you very much. We will again meet in the live session too.